Here's problem 3120. A conducting bar of length L rotates with a constant angular speed of +2 radians per second by a pivot P at one end. A uniform magnetic field magnitude 0.2 Tesla is directed into the paper. If L is 0.4 meters, what is the potential difference VA minus VP? Here's our pivot at point P, and we are moving with an angular velocity of +2 radians per second, which means that our angular velocity vector is coming out of the page in the positive z direction towards u, and we are rotating counterclockwise in that direction. If we were to consider a electron on this conductor with this magnetic field going into the page, 0.2 Tesla, and that electron is actually moving at this moment with a velocity as such, V cross B would be pointing to the left, but because it's a negative charge, the magnetic force on that electron will be to the right. What this means is that we're going to end up with our electrons developing on the right and positive charge developing on the left. Point P will be more positive in voltage than point A, and if we define P to be 0, then point A is going to be at a negative voltage with respect to that. So let's keep that in mind. Our L in this case is going to be the distance to point A, and that's going to just be half the distance of the whole rod, so that's going to be 0.2 meters. Of course, angular velocity is 2 radians per second, and magnetic field is 0.2 Tesla. So our EMF, at least the magnitude of the voltage, is going to equal B omega L squared over 2, which is going to be 0.2 times the angular velocity of 2, L is 0.2, squared, divided by 2. 2's cancel out. 0.2 times 0.2 times 0.2 is 8 times 10 to the minus 3. That's the magnitude of the potential difference. But point A is less voltage than point P, and P is 0. So the voltage at A with respect to point P is going to equal a negative of this value, which would be a negative 8 times 10 to the minus 3 volts. So VA minus VP is a negative 8 millivolts.